Now let's look at making inferences about two population variances. Now we have two populations. The first population has a variance of something. The second population has another variance. Or it could be standard deviation. You can set up the hypothesis in either format. Okay. And we want to test the relationship or whether these two are same or one is larger than the other. So there are three formats for the hypothesis, like we have seen many times now. A left side one tail test where the alternative is sigma sub 1 squared is less than sigma squared sub 2, and the right side will be greater than, the two tail will be equal to or not equal to. So you can set this up as standard deviation also, okay, in which case it will look something like this. Now then we take independent random samples from the two populations. So sample size, sample variance, and of course sample standard deviation will be square root of that. So the second sample, independent random sample from the second population. Okay. Now we don't have confidence interval in this case because there is sigma sub 1 squared minus sigma sub 2 squared has not a whole lot of meaning. So we only have hypothesis test. And when we take a ratio of the two variances, remember, if the variances are given, you divide one by the other. If it is a standard deviation, then you have to take the standard deviation, square it, and then you have to make a ratio. Now, in Excel, it really doesn't matter which of these two variances goes in the numerator and which one goes in the denominator. But if you use the F table from the textbook, then the F table is given only for the right hand side tail areas, and therefore you have to use the larger variance in the numerator and the smaller variance in the denominator, so you'll always have the F value on the right hand side tail. Then the F distribution looks very much like the chi-square distribution. If it is a one tail test, you will use alpha. If it is a two tail test, you will use alpha over 2 for the F table value. And here are the Excel functions for the F table value. So F dot INV, and then you use alpha and the 2 degrees of freedom for the numerator sample, n minus 1, and then the second degrees of freedom is the denominator sample, and the n minus 1 for that sample will give you the 2 degrees of freedoms. And if it is a one tail to the right side, then you'll use F dot F dot INV dot RT, and alpha on the 2 degrees of freedoms. And if it is a two tail test, again it is INV, you use F dot INV for the left tail and F dot INV dot RT for the right hand side tail, and you need to divide the probability by 2, alpha over 2 and alpha over 2. Now for p-value, the Excel function, you use similar function. Instead of INV, you use dist. F dot dist for the left side tail, and use the calculated F here. And don't forget the comma minus 1 in the F dot dist function. And for the right hand side, you use F dot dist dot RT. And when you use RT function, the comma 1 is not necessary. Now for the two-sided test, two-tail test, again you use the left side tail and the right side tail, okay, and take the minimum of the two, like in the chi-square test, and multiply by